Hey everyone, my name is Mert and this is the first video that is not Turkish on my YouTube channel. So let me know in the comments if it's any good or I should just stop making content in English. What we are going to do in this video is building a GraphQL server from scratch, and I'm going to be using Typescript. If you're using VS Code, you may just want to open Extensions tab and find the GraphQL extension. This one. GraphQL for VS Code. It's nice, it supports syntax highlighting for GraphQL files, so you may just want to install it. And other than that, all you need is Node.js installed on your computer. After that, I'm going to write npm init-y to create a package.json file. This file will hold our application information, such as name, version, description, entry point of our application, and we are going to create two scripts here. After that, I'm going to install Typescript as development dependency. And not only that, just like package.json file, we need tsconfig.json file. It will hold the compiler option for Typescript. I'm not going to do it manually. There's a package called tsconfig.json and I have installed it globally. You can add it to your project as a development dependency, or you can just call it by npx. I have it globally installed, so what I need to do is just type this one, tsconfig.json. And I'm going to select node, and it will create tsconfig.json file, and there are a bunch of options for TypeScript compilation. I'm not going to change any of those because I'm happy with that, but if you want to change them, you can just do that. I don't know why it shows an error, but if I close VS Code and open it again, I don't think there will be any problem, so let's do that. I reopened VS Code and it shows no errors, so we're good to go. Next step will be creating a source folder and installing required packages to create a GraphQL server. I'm just going to add GraphQL and ApolloServer. ApolloServer enables us to create a GraphQL server and it uses Express under the hood. Also, we need one more package and it is Nexus. Nexus is a library to create type-safe GraphQL schemas, so we will generate the schema with Nexus. I'm going to create a new file under source index.ts and schema.ts. We can create our schema right here. I'm just going to import make schema from Nexus and import join from path to specify the directories for our outputs. And I'm going to export a constant called schema and it will be equal to make schema. It returns Nexus GraphQL schema, but we need to pass some options such as types. Since we don't have any types at the moment, I'm just going to leave it as an empty array. But for outputs, we will have two outputs. The first one will be schema and we will call join process.cvd and the name of the file will be schema.graphql. We need to put it in quotes, so we're good. And second one will be typegen. This file will hold type definitions for our schema, and I'm just going to copy this one, paste it here and change it to nexus typegen.ts. With that file, the generated types will help ensure type safety in our application. So this one is important and this one will hold our schema. And in order to run this one and create these outputs, we just need to go to index.ts. The first step will be importing ApolloServer from ApolloServer and creating a boot function that will have the initial setup for our application. What I'm going to do here is create a server constant and it will be equal to new ApolloServer. An ApolloServer will take some arguments such as our schema. We have export our schema here, so all we need to do is pass it here with auto import, but it didn't automatically import it, so I'm just going to import schema from schema.ts. And after that, we need to start our server. So just like Express server, we will call listen method and it will take the port we will be listening to. Then we can access the URL that we are listening. So I'm just going to console log it. Console log listening on port, no port, listening on, and then URL. So this is what we will see in our console if our application successfully starts. So I'm going to call boot function, and that's all I need now. But the problem is we cannot directly run TypeScript files. First, we need to compile it to JavaScript. So I'm just going to create a script for that, and it will have the name watch. What it does is calls TypeScript with watch flag. So whenever we make a change on our TypeScript files, it will automatically detect it and compiles it to JavaScript. And then since we have the JavaScript code, we will be able to start and execute our server, our JavaScript code. So after writing the script, I'm just going to call yarn watch to start this script, and we will have a dist folder here. So inside of the dist folder, we have JavaScript files. This index.js is actually index.ts, but it is compiled to JavaScript, and if we run this code, our server will start. And I'm going to split my terminal. I'm just going to install one more package as a development dependency, and it will be NodeMon. Maybe most of you guys have heard of NodeMon, but in case if you haven't, it's a package that allows us to start our server, and on every change on our code, it will automatically restart the server, so we don't have to stop it and start it again. And I'm going to write a new script for that under watch. Oops. You can call it start or dev or whatever you want. So I'm going to do is call NodeMon, and with NodeMon I'm just going to start index.js. So dist/index.js. I'm going to hit save and yarn dev. Okay, this is the first time we have run our code, and our server is listening on port 5000 on localhost. If we close this, we notice that we have two new files. First one is the schema.graphql, which will be our schema. And the second one will be our type definitions, and we don't have to care about that much right now. But if you look at our schema.graphql, we have only one type, query, and this query type has an OK field. I know this sounds a bit complicated and it doesn't mean nothing to you right now, but since we start writing our resolvers, you will understand what's going on with queries, mutations, or subscriptions. But if we go to localhost 5000 to see what's going on, this is the page that welcomes us to localhost 5000. I'm just going to hit query your server, and it will redirect me to studio.apollo.graphql. This is the place where we can test our queries, mutations, subscriptions, all kind of API stuff. So you can think that as a client, if you have worked with Postman to test your API, this is the same thing. We are testing our API with executing queries or mutations. We only have this one. If you go to schema, we see that we only have one type. This is query, and query is a special type that defines the entry point of every GraphQL query. So since we haven't defined anything for our schema and we don't have any resolvers, any object types, GraphQL automatically generated this one. Otherwise, the query type is the same as any other GraphQL object type, and its fields work exactly the same way. So we are seeing this because we don't have anything else. It's the default schema. So if we go back to Explorer and execute this one, we will have the data and it says OK to true. So it is a simple API response. If you have worked with HTTP, you're familiar with it. But you may be asking what's going on here. So we are executing a query and we are defining query like this, just using the query keyword. And this is optional. So maybe you don't want to use any name. So it turns to unnamed. But if you want to keep things organized, you can say that this is an OK query. And what we get from this query is its OK field. So we are executing a query, and in return we want the OK field, and it returns as true. So this is what's going on here. I know it's still complicated, but we will be writing our own queries in a minute, so don't worry. Before moving forward, I just want to talk about GraphQL schemas. GraphQL schemas are defined in a special language, GraphQL schema definition language, and has 3 root types. The first one is query, the second one is mutation, and the third one is subscription. Actually, these 3 types are supported operations offered by GraphQL. So what we are doing here is we have a query type and we are extending that type, and we have a new root field. So whenever we go back to our studio and type OK, it will return either true or false. It can't be null because of this exclamation mark here. If you use exclamation mark, it means that this field is non-nullable. For example, let's have mutation type. And this mutation type will have create product mutation. So this is again a root type, and I'm extended that root type and creating a root field. So I will be able to call this create product mutation in my server. What it's going to do is insert a new product to database. And we can pass some arguments. For example, our product will have a name and it will be a string, of course with exclamation mark. And what will it return is a product type. But at the moment we don't have a product type, so let's just create a product type. And product type will have one field, name, and the type of it will be a string. Also, maybe we can add an ID field, and type of it will be number. Mutation can be used for updating or creating data. Query is for getting data. And this is our product type, which has 2 fields, ID and name, and this mutation returns a product. That was a quick explanation about what's going on with our schemas. Okay, so let's get started by creating our first resolver, our first query. I'm going to create a new folder here, and the name of it will be GraphQL, and I'm going to create a new file, and it will be product.ts. In this tutorial, I'm going to be using a product type and a user type. I just wanted to start with product because it will be much simpler. We don't have to deal with authentication and other stuff. So what I'm going to do is create a new type for a product, and let's see if we can get it here in our schema. Export const product type. You can call it whatever you want. I'm just trying to keep it simple here. Then we call object type from Nexus. It will create a new type, a new object type, and we have to pass some arguments to it. For example, name of our object type. The name of our type will be product. So we will have a new type here in our schema, hopefully. And we can define the fields we want by using definition. This T represents type. So our product type will have non-null integer field, and its name is ID. So we are going to hold ID of a product. And again, non-null string, and it will be the name of the product. And lastly, non-null float. I'm using float because I want to use decimal places for the price. And these are the 3 fields for my product type. This is enough for now. So let's hit save and go here to our types. So we need to insert our type here in order to see the changes in our schema.graphql. Also get the type definitions for our product type here. So what I'm going to do is, since I'm going to have more than one GraphQL file here, I'm just going to create index.ts and export every resolver, every object type from here. Export all from product. And what I'm going to do is go to my schema.ts and import everything as types from GraphQL. That way I will be able to get all definitions from this folder. And this is what I'm going to do. I'm just importing everything as types and passing these types to make schema function. That way I will be able to get my type definitions and types in schema.graphql. As you see, we have a new type here and 3 fields as we just defined, so everything's cool. Now what I want to do is create a simple query that will get some sample products, but we don't have a database connection at the moment, so I'm just going to create a new array. The name of the array will be products, and the type of it is important, so I'm going to go to Nexus typegen.ts, and we will have in, where is that? Nexus gen objects, we have a product here. So if we get this type, this is what we are looking for, because we have a product field, and this product field will have 3 attributes and their types are defined here. So my array will have Nexus gen objects, and then what I'm going to get from Nexus gen objects interface is the product. So to get that, I'm just going to write products here. No, is that product? Product, okay. So I got it now, and the return type will be an array of it. So let's import that one. I don't know why it didn't autocomplete, but Nexus type gen and then Nexus gen objects. Okay, cool. So I'm just going to have initial values. I have 2 products here, as you see. Then what I'm going to do is create a new query to return all products we have. Right now we only have 2 products, but when we connect to our database, we will have more than 2 products. Let's create a new query. Again, you can call it whatever you want. So I'm going to call it products query, and that will return export const. That will return products. And we are going to call extend type from Nexus. So which type we are extending. Since we are creating a query, we are going to extend query type. As we talked about, it is a root type, and we are creating a root field of it. So I'm going to call definition again and define the type that will be returned. So what I want here is non-nullable list. List means an array, so we are going to return non-nullable list, and this list will have non-nullable product type objects. So I'm just going to name my query as products, but you can do it whatever you want, so get products or whatever, so it's not that important, it's just the name of it. What we need to do is define the type of our object. We are going to return non-nullable list, and in that list we are going to have non-nullable product type objects. This is what we are doing here. So this is just the name of our query, and this is the type of our objects that we are returning in a non-nullable list. And we are going to call resolve. Every operation has its own resolve field. So it takes 4 arguments. Parent, we're going to use that in a bit, so I'm just not going to explain it right now. Arguments, also we are going to use that. It's not too hard to guess what it is. And context, also we are going to use that, but info, we are not going to use that. And the reason I'm putting underscore here, if I don't, it will just cry and say parent is declared while its value is never read. So I'm just going to put an underscore here. So I'm saying that I'm not going to use that, and compiler won't cry because of it. So what I'm going to do here is, you can think this as a method body. So it will execute, this resolve method body will execute whenever we call our products query. So what I want to do right now is just return the product. So let's write this down. Cool. So we have a product query, and whenever we execute that query, it will return products. We should have seen something different here rather than OK query, because we just defined a new query field type, but we don't see it here. So I guess it has to do something with compilation. And if we go to our this folder, we have index and source here, but what we are doing is in our package.json not calling the index.js inside of our source directory. So I'm just going to delete that real quick, delete this folder and close this one. Close this one and call yarn watch again to create a new dist file and see more clear version of a dist folder. So as you see, we got now a source folder and we have everything inside of it. So instead of calling dist/index.js, I'm just going to call dist/source index.js, and I'm going to yarn dev. Okay, so let's go back here. As you see, we have compiled our code correctly, and we have a new field here, products query, and what it returns is a non-nullable array of non-nullable product, as we just defined right here. Non-nullable list, and we have non-nullable field inside of it, and the type of that field is a product. So we are defining the object type we are returning. And what we are going to do with our resolve function is return the product. So let's test that out. Let's go back to localhost 5000. Okay, so we can get rid of this. Instead, we have products query. And we don't have an OK field inside of it. You see, cannot query field OK on type query, because we now have products here. And inside of our product type, we have ID, price, name. So this is one of the best things about GraphQL. We are executing a query, products query, and GraphQL knows which object type we are returning from our query. You don't have to create a new route for every field. For example, all I need is ID. Then all I need to execute is this one. I'm just going to get all products but only ID of it. So I'm just going to execute that. As you see, we get only ID in return. But what if I want to get ID and then price? Let's execute it and we get the prices back. Also, let's get the name of them. So we get all three fields. In client, you can define which fields you want from API, and that's a great feature. And congratulations, you just created your first query and executed successfully. What if you want to create a new product? What we are going to do is extend mutation type and create a new mutation. I'm just going to declare a new resolver here, and the name will be create product mutation or whatever you want to call it, and extend the mutation type. And I'm going to define what it will return. What it returns is non-null field, and the name of the mutation will be create product for me. You can call it whatever you want, and the type of it will be a product. So I'm going to return a non-nullable product. Since we are creating data, I'm just going to take inputs from user, and the two inputs will be name and price. So I'm just using args here and declare my arguments here. First one will be name, and name will be a non-null string arg. So user cannot send a null value for our name input, and I'm going to do the same for price, but this time it won't be string arg, it will be float arg. Great. Now what I want to do is resolve. I'm going to call, just take all of those and paste it here, and we are going to use arguments this time. We are taking inputs from user, and in order to access these arguments from our resolve function, we need to use args. These arguments passed here. So what I'm going to do is, first of all, get name and price from arguments, and then create a new object const product, and this will have name, price, and let's put ID up here. So the ID will be automatically set by database, but since we don't have any database connection, we are going to put that manually here. So what we can do is we have an array, and we can set the new items ID as the length +1. Okay, cool. So here I'm just going to say products.length +1, and then I'm going to push my product to products array, products.push and product, and return the created product. Okay, then I'm going to yarn watch and then yarn dev, I'm opening a new workspace here and I'm going to call a mutation. The mutation name will be create product, and we have extended the type of root type, the mutation type. So we've got a new field here and the name of it will be create product. I don't want to do that actually. I'm just going to put it like this, and arguments will be name, my first product, and the second argument will be price and $10.99. So in return, we are returning the created product, so I can grab the fields of a product, for example, ID, name, and price of the created product. So I'm just going to hit here and see we have a new product, and ID is 3, name is my first product, and price is $10.99. But if we want to stop our server or make a change on our server and restart it again, since we're using an array here and it's in memory, all of our changes will be gone. So we need to create a database connection. And for database, I'm going to use PostgreSQL. But before moving on to that, let's just console log our products after pushing a new product and see in the console if it's working or not. So we have pushed the data, but since we changed our code and NodeMon automatically restarted our server, we just have 2 items again. So I'm just going to create product again and go back here and see the array of products. We have 3 items. Let's add another one, my second product, and price will be $11.99, and create product and go back here. Great, it's working. Now let's create a database connection. I'm going to be using pgAdmin to manage my PostgreSQL database, and leave a link in the description in case you want to download it and use it. It's a great tool, and what I'm going to do is create a new database by right-clicking databases and set a name, Apollo GraphQL. It wants us to select an owner for our database. I'm going to select Postgres. This is the default user that gets created by pgAdmin. And if I remember correctly, whenever you create your first database, it wants you to set a password for that user. And this is important because we are going to use that credentials to connect our database. I'm just going to hit save here. And we have a new database here. Before moving forward to our application, what I'm going to show you is right-click PostgreSQL 14, go to Properties, and we have a connection tab here. I have set my port as 9999, but if you're using pgAdmin for the first time, the default will be 5432. This is important because we are going to declare a connection string, and we will use that value for our port. So I'm just going to open a new terminal here and add a new package. I'm going to be using TypeORM for all kinds of database management things. In order to connect our database using TypeORM, I'm going to create a new file here. The name will be typeorm.config.ts, and we are going to export to default a new data source. And if we call data sources Initialize method, it will create a connection, but we are not going to do that in this file. We are going to do that in our index.ts file. A new data source will have some options, such as type of our database. We are using Postgres, and we need to pass an URL here. But we are not going to keep that URL like a string here because it's unsafe. We will have some important information such as database username and database password. It won't be a problem since we are working on a local database, but it's a best practice, and what we are going to do is create a new file .env. And inside of .env, we are going to keep our connection string. But first of all, let's add .env and go back here, import .env from .env and call .env's config method to get all kinds of keys, but we don't have any at the moment. Connection string will be our PostgreSQL database connection string. So the value will be PostgreSQL, and then the name of our user, we have set our owner as Postgres, and the password for that user is 123456 for my case, but you need to put your password here. I'm running my database locally, so I'm on localhost, and the port for me is 99999. And after that, the name of our database, Apollo GraphQL. So that string, we will be able to connect our database. So I'm just going to put that here, process.env.connection string. If we go back to our index file, not that one, this one. Okay, so before creating our server, we can connect our database, and const connection will be equal to await. Because we are using await, we are going to declare this function as async. We will be calling TypeORM configs initialize method, and this returns a promise, so we need to await that. So that's why we declared our function as async. And we have a database connection. This TypeORM config just comes from here. We just export default a new data source, and we are calling that data source's initialize method here. We are not doing anything with that connection, so I'm just going to delete that for now. And let's see if we have any errors. Oh, I forgot to install pg package. So we are creating a connection to PostgreSQL, and in order to use PostgreSQL in our application, we need to install pg package, which is a Postgres package. It's all good now. The reason we are connecting to a database is we want to get data from database and create some data and insert to our database. So what I need is a database table, and I'm going to create a new folder for it, and it will be entities folder, and I will have product.ts. So I will have a product entity. So let's call entity, which means a table in our database from TypeORM. This is a decorator, and that says we will have a table under that. So I'm just going to export class product. The name of the class will be a product. And we can extend base entity, since this will be one of the two entities and it doesn't depend on any other table. And the first field will be an ID, because we declared here we have an ID field. So let's do that, and it will be primary generated column. And this means that this ID column will be our primary key for product entity, for our product table, and generated means it will automatically generate it, and we don't have to pass anything to generate that. So it will start from 1 and go forever. And we will use exclamation mark here as we did before, and I have other fields, but they will be just normal columns. First one will be the name, and the type of it will be a string, and the second one will be the price, so the type of it will be number. We can also use some additional fields such as create that, and we have some special column that comes from TypeORM, create date column, and we don't have to do anything about that. It automatically assigns a value whenever we create a new product, and all I need to do is specify the name, and the type of it will be date. We can do the same thing for update date column, so whenever we update a document, it will be automatically changed. Okay, so these are the initial values, initial columns for my database, but what should I do to see that table inside of our pgAdmin? Because at the moment, if we go to schemas and tables, we have nothing here. What we need to do is insert our entity to our database. And to do that, let's go back to here, TypeORM config, and we have an entities field here. And this is an array and takes entities. So we have product entity, and we are going to import that from entities/product. Great. If we hit save, we will see that nothing will happen again. So let's just refresh that, and we see nothing's happening. So in order to make changes on our database, such as inserting a new table here, we need to create a migration. But since we are in the development stage, we don't need to do that. All I need to do is set synchronize as true, So whenever we make a change on our data source, our database will be automatically affected and will get the new changes. So if I hit save here and go back to my database and refresh that, I see that I now have a product table. So let's click that and select query tool and select everything from product and execute that. As you see, we have ID as primary key, name as a string, and price as an integer, but we don't store integers, so we are going to change that. Let's go back to our entities and pass an option here. So you can pass options to columns like this. The type of that column will be a decimal. So let's hit save and go back to our database and hit save again. As you see, it has changed to numeric, so we will be able to use decimal places for our prices, and we have created that and updated that column. So it's too easy to send our entities to our database like this, but we don't use that synchronize true in production stage. But we are testing our application, so it's always good to use that one. It makes the process much easier for us. So what I want to do now is go to my product resolver, and instead using that products array, I'm just going to comment that out and then delete that, and I'm going to change my query here. I'm not going to return a product here. What I'm going to return is a promise, because I'm going to be dealing with my database, and this promise will resolve to a product array. But the problem is we don't import that, so let's quickly import product. It's coming from entities, so great. All we need to do is just return product, and this product comes from entity. We just auto imported that here, but it's not from source. It will be this one, okay? Product.find, and if you don't pass an option inside of this find, it will get all rows from product table. That's all we need to do to get all products from our database. It's really easy with TypeORM. Let's get rid of this, and the return type will be a promise again, and this promise will resolve to a product here. So I'm taking name and price from arguments, and what I'm going to do is just return product.create, and then I'm going to pass the arguments that I got from my user from arguments, name, price, and then I'm just going to call save, and this save will return a promise, and this promise will result to a product just like we declared here. So I'm just going to hit save. Seems like everything's okay, so I'm going back to my create product mutation, and this time it will directly go to my database. So let's change that to my first product, and I don't know why this is 3, so let's go back to our database and select everything from product. As you see, it didn't work, so we have a problem here. I don't know why my this folder keeps get messed up, so let's delete that again. So yarn watch again. Okay, so let's have a look. We don't have a source folder. Okay, let's go back here and change that to that. Okay, hit save, and then yarn dev. I don't get it, but as long as it's working, it's just fine. So let's try it again, and we have our first product and ID is 1. If we go back to our database and execute this query to select all products, we see that we have inserted a new document to our database successfully, and created that and updated that fields are set automatically. So let's create the second product. The price will be $12.99, and create product, and we have another data. Execute it, and we have the second data. Great. Let's try to retrieve all the data from our database using a GraphQL query. We have already changed the code, so what we need to do is just call it, and it will retrieve all of the products from our database and the fields that we want. Let's just get IDs. Okay, cool. Great. We have used our product base entity and its methods to create data and get data. But what if you wanted to do that by executing a query? Or maybe you want to do something specific that can't be done by these methods. What we need to do is use our third argument here, context. Whatever we pass into context will be accessible from all of our resolvers. So that means I'm going to create a query builder by using my connection. And what I need to pass to my context is my connection. Initialize method will return a data source, and I'm going to grab that and keep that in a constant con. This con will represent my connection to my database, and I'm going to pass that to my context object. That way we will be able to access that in all of our resolvers. So I'm going back here and declaring the context field. It is a function that returns my connection object. In case you're wondering how this connection object or whatever is inside of these brackets will be passed to our resolvers, we have declared our schema here, and if we go here, we have everything from GraphQL folder. So inside of our GraphQL folder, we will have our resolvers. That way, our ApolloServer will know where to pass this context object, and we will be able to access it from all of our resolvers. So we have our connection object, and what I need to do is go here, delete this, and for now I'm just going to comment it out, and I'm going to grab connection from my context and connection.create query builder, but it doesn't autocomplete because we haven't declared the types here. What I'm going to do is create a new folder called types and create a new file. You can call it whatever you want. I'm going to call it context.ts and export new type context will have connection, and the type of connection will be a data source. So I'm exporting that type, and I'm going back to index.js, and did I say JS? It's index.ts, and the type of it will be context, and it comes from types/context. So I'm passing that and saving, I'm going back here, and the type of this context object will be context. So let's do that. Now I will have auto completion. As you see, we have our methods here, and I'm going to call query methods. Inside of that, we will write our query. In that case, I'm just going to select everything from my product table, and this returns a promise, and we are returning a promise, so I'm just going to return that one. So everything's cool. Let's hit save. I'm back on my studio, and I'm going to execute that query, and we will have our products, but let's grab all of the fields. Okay, cool. I'm not going to use queries here because what we're doing is pretty simple. We're just calling find method, and in create product it is really simple again, so I'm not going to use queries, but in case you want to use them, I just wanted to show you how we can do that and how we can pass our connection object to our resolvers. We are going to use that one more time while authenticating our users. Let's continue with our user table. What I'm going to do is create a new entity, and the name of the file will be user.ts. I'm going to copy everything from here and paste that. So the name will be user, and we will have a username column instead name, and paste that here. The second column will be password, and I want to add our email column. So these values look fine to me, and the next step will be sending this entity to our database. In order to do that, we have to go to TypeORM config and add our user table, our user entity, to entities array, and I'm just going to hit save. Let's go back to pgAdmin and refresh tables, and we see that we now have a user table. Next step is creating a relation between user and product tables. With that way, we will see how can we create a relation with TypeORM. And the relation will be one to many for user table, because one user can create more than one product, so user will have products. That's why I'm declaring my relationship as one to many in my user entity, and this decorator comes from TypeORM, and the first argument will be the entity we are establishing a connection with, so product entity, and I'm just going to import product from entities folder, and second argument will be the corresponding column from this entity, which is product in our case, that has this relationship. So the column will be product.creator. It will cry because we don't have a creator column at the moment in our product table, but we are going to create that in a bit. So the name of this field will be products, and the type of it will be a product array. Now we are going to fix that one. Let's go back to our product table and declare the same relationship here. This one will be many to one because we have used one to many in our user table, and we are going to define the same relation with user table in our product entity. The entity I'm establishing a relationship is user. I'm going to import user, and user already has a field for that relationship, and the name of the field is products. Users products field will hold that relationship, and we are going to declare our creator field, and the type of it will be user. We put creator here, and if we go back to our user entity, we see that it doesn't complain anymore because we have this relationship also in our product table, and we defined this one as creator just like we did here. So our columns are matching for both tables. We have user.products and we have created our products relationship here. Also we have product.creator, and our product table now have a creator, and this creator represents a many to one relationship. So I'm just going to hit save and see what's going on. I'm back in pgAdmin and select everything from user, and if I execute that, I see that Postgres is returned because user is a special table in Postgres. If we want to access the table we have created, we are going to put double quotes and it will work fine. As you see, we have accessed our table. If we didn't put double quotes here, what it returns is our database user, one and only Postgres. Let's get everything from our product table. As you see, we now have a creator ID field, even though we didn't declare something like that. The reason we have a creator ID field because we have declared a many-to-one relationship, and the name of this relationship is creator. Postgres automatically adds a column to hold creator's ID. That's why it added ID at the end of this keyword and created a new column. So what I'm going to do is actually put that one here, creator ID, and it will be a mandatory field. So every product must have a creator. I'm just going to hit save. Creator ID of relation product contains null values. As we've seen before, our creator ID fields automatically set to null because we have just added that column. So what I'm going to do is delete from product and execute that one. So now we have an empty table. Let's select again. Okay, so it's all good, and now we are going to pass our creator IDs so we won't have any problems. We have created a user table, but we didn't create a GraphQL schema. So what I'm going to do is go here and then create a new file, user.ts, and declare a new object type for our GraphQL API structure. Import object type from Nexus, and then export const user type, just like we did with our product. Maybe I can copy that actually. Let's copy that and paste that here and change this to user type. And the name will be user for our object type. And we are going to set our fields here. Again, we will have an integer. And let's go back to our entity. We have this one. We have username, password, and email. So I'm just going to put that. This will be username, and then again a non-nullable string. It will be a password, and then non-null string again, and the name of it will be email. These fields are same with my entity, so I'm good to go. Now I can expect arguments from client, get them, and create a new database record or database row, whatever you want to call it, with that arguments. And if we go here to our schema, we won't see nothing because we need to export everything from our user object type. Okay, and let's go back there again. And we see that we now have a new type here. Great. Before moving forward, I just wanted to mention a quick thing here. You may be wondering, why did I put this column here? Because when we first initialized this many-to-one relationship, our database automatically created a creator ID field, and we didn't have to define it again. But let's see what happens if we delete that and go back to our database, refresh my table, and go to properties. We have a creator ID column, but it's nullable, and I don't want that. That's the reason why I did put column here and rewrite this creator ID field and put an exclamation mark here. I wanted to explain that because when editing the video, I thought it may be confusing, and yeah, I just wanted to mention that. Now the next step will be creating new resolvers to register and login. And I'm going to do that in a new GraphQL schema. I have declared my schema here, but I'm going to return not just the user. I'm going to return user and the token. We will use JWT authentication and authorization. That's why I'm going to create a new object type, and this object type will have user inside of it and also a token, which is a string type. So let's create a new file. The name will be auth, or whatever you want to call it. The first thing will be export const auth type and declaring a new type as we did before, and it will be an object type. And the first field will be our token, but before declaring that, I'm just going to name that object type as auth type. And after that, we are going to call definition, and the first field is non-nullable string, and the name of it will be token. Oops. And the second one will be our user. So we are going to return a token and user. And to do that, I'm just going to define a non-null field. And the name of it is a user. And we are going to specify the type of that field. And the type will be user. And that will come from our schema because we have a type. And we are going to use that type. I'm going to save that and go back here, and I'm going to save that too. We are going to use that type in our auth type. That's what we will return from our sign up and login resolvers. And let's go back to index and export everything from auth. Let's create a new mutation, and I'm going to call that auth mutation. And what I'm going to extend is extend type mutation, just like we did on our product resolver. And we will have two definitions here, but the first one will be our register resolver, because first we need to create our users, then we will log in. We will have a definition here, and the first one will be a non-nullable field, and we are extending mutation type, so we are creating a new mutation here, and the field name will be register, or you can call it sign up or whatever, and the type of it will be auth type, because we have declared our return type and it has a token and string, and that's what register resolver returned. So after declaring our type, now we can declare our arguments. We are going to need a username, and the username will be a non-nullable string arg. And we will have an email field, and also we will have an password field. And lastly, we will have an async resolve function, we are going to grab parent, but won't use that, and we will use our arguments. We can use our context, and the type of context is context. We have declared it here. We are still using that, and let's change this to this, and the last one will be information. First step is grabbing our username, email, and password from our args. Next step will be hashing our password, because we don't store our password as a plain text. It is not safe. And the package I'm going to use is argon2, yarn add argon2. And it is type safe, so we don't have to install types for that package. And let's go up here and import argon2 from argon2. Great. We are going to have an hash password constant, and this will be returned from argon2's hash method, and we are going to pass our plain text password inside of that. Okay. Since this returns a promise, we need to await that, and our function is already async, so we are good. Let's declare a user and token, and we will return them if everything goes well. And I'm going to open a try catch block here, and if we have any error, let's console log it. And maybe we can throw an error, but let's just implement the logic. What I'm going to do is create a query builder. So we are going to see how can we use query builder. So our result will be await context.com. We have it in index, not that one. Here, context includes our connection, and this is our database connection. So we can create a query builder by calling its create query builder method. And the operation will be inserting a new row to our database. So I'm just going to call insert. Then which table? My user table. I'm just going to import user. And I'm going to specify the values I'm importing. So I have username, email, and password. Username, email, and password will be hash password. Okay, and we are going to return everything. Returning all. I'm going to call execute method to execute my query. We don't know what our result looks like, so it may be something that we don't want. We might need to destructure this result a bit. So what I'm going to do is just cut that out and then comment that out. Go back to my index.ts. What happened? I'm just going to comment all of that. Okay. I'm going back to my index here, and let's do that. Context, we don't need that, we already have connection here. And import this, and values will be username, mertstack, email will be mert@gmail.com, and password won't be hashed, but it doesn't matter at the moment. I'm just going to call argon2's hash method here, or just pass 1 2 3 4 5 6 for now. And after that, I'm just going to console log the result to see what it looks like. I'm just going to hit save. This is a wrong import, but we don't need that actually here, so let's delete that. Okay, cool. We have our result in our console, and we need to grab row's first element, because in response, we have a row field, and this field is an array, and array has only one element, and this element is the created user. And if we go back to our database and execute that one, we see that we now have a user, but I'm going to delete from user because I don't want my password to look like this. Let's we didn't put double quotes, so okay, we're good now. I'm going back to my resolver here, and let's cut that, save it, and uncomment that, and we now have what to grab. user, let's uncomment that out. User will be equal to result.row and then its first element. And we are going to have a token. In order to deal with JWT, let's add yarn add Json Web Token. And we need to install types to get type declaration. Add types Json Web Token. So let's go up here and import everything as JWT from Json Web Token. Cool. And let's create a token. Token will be equal to JWT.sign, and the first parameter will have our variables that we want to hide inside of our token. And I'm going to have user ID, and user ID will be equal to our created user's ID field. After decoding my token, I will be able to access this user ID field. With that way, I will be able to check if the person making the request is owner of the product, creator of the product, or not. That's one way to do that. But you can add more variables here, such as email or full name, but user ID is fine and will work for most of our cases. So this is what I want to do. And the second parameter will be our token secret, but we are going to hide that in our .env. It is a secret, and I'm just going to generate a random string here. I'm going to type node here and then require crypto package and create a random 64 bytes secret, and we'll call toString method. This will be our secret. You can do the same, or you can put a dummy value such as my secret or whatever. Our token secret will be this one. So I'm just going to hit save and go back to my auth. It wants us to enter a secret here. I'm going to call process.env.token secret, and I guess that's it for now. Let's hit save. We have a problem here. String undefined is not assignable to parameter of type secret. So what I'm going to do is cast that to JWT packages secret. Cool. So we won't have any problems with that. And I'm just going to return this two variables, user and our token, because we have declared our return type as auth type, and auth type has two fields. Well, first one is token, second one is user, and we got them both. So let's do that. Return user and token. Cool. Create a new workspace, and I'm going to call a mutation because I have extended mutation type, and the name of it will be register. We have defined our resolver's name as register, and we will have some arguments such as username, stack, and then password. Password will be 123.6, and then email will be matt@gmail.com, and in return I will be able to access users fields, user, and then email, ID, password. Let's see passwords, if it's hashed or not, and then username. And also we can grab our token, so I'm just going to write that down and register. And we see that we have our data back. We have matt@gmail.com, ID is 2, password is hashed, and we also have a token here. And the token is valid for some time, but we didn't specify that. You can do that if you want. We forgot something, and that is making our username and email fields unique, because we won't have two users sharing the same username or sharing the same email. And to do that, we are going to pass an option, and unique will be true. And I'm going to do the same thing for my email field, and I'm just going to hit save, and that's it. We now have our register resolver working, and let's try signing up with the same email or username. I'm just going to hit register again, and I will have a problem here. Let's try another one. Mert Akpinar, password will be the same, and Mert Akpinar. Okay, it works fine. You can create a more custom error handling, but I won't do that in this tutorial. We got our register resolver working, so what I'm going to do is create a new resolver, and this will be login, and the type of it will be again auth type, because we are returning the same thing for both registering and logging in. I'm going to define this one like that, and for arguments I'm going to need a username, and this will be a non-null string arg, and I will have a password, and this will be again the same thing. Let's copy this and paste that here. We are going to do the same thing, but this time we are going to search a user in our database by using this username, and if that user exists, we are going to check the passwords. If they are matched, we are going to return a token. So what I'm going to do is grab username and password from our arguments, and then call user entities find method, and we are going to pass filter here where our username is equal to given username. If that returns a user, we do have a user with that username, so what we are going to do is check the passwords. But before that, if there is not a user, what we are going to do is throw a new error, and the error will be user not found, or whatever you wanna call it, and then we are going to check our passwords. We can declare a constant is valid, and this will be equal to argon2's verify method. Verify method takes two arguments. The first one will be the hashed password. We got our user, and our user's password in our database is hashed, so the first argument will be user.password, and the second one will be the password that client sends us. It's a plain text, and we are going to put that here. We got a problem here. It says property password does not exist on type user array, but we are going to retrieve only one user. The problem here is we have used find method, and find method returns an array of users, but all we need is just one user, and since the username is unique, if we have a user with that username, there will be only one record, so we don't need to return an array. We can either do this one or just use find one method that returns only one row. It doesn't complain anymore. And after checking the password, if is not valid, we are going to throw an error again. Throw new error, invalid creds. If we didn't throw an error so far, credentials are correct, we do have a user, and let's create a token for that. Token will be again jwt.sign and the credentials, and I was just inserting user ID here, and the value will be user.id, and then we are going to pass our secret process.env.token secret, and then as jwt.secret. So we have our token. Let's return our token and user here. I'm going to hit save, and what didn't we? So we didn't use our context, so I'm just going to put underscore here. Okay. Let's create a new workspace, and we are going to call a mutation here. Name will be login, and then we have extended the type mutation and created a resolver, and the name of our mutation is login, and we have to pass a username, but I forgot my user's username, so we have a user like that. So what I'm going to do is put that on here. Username will be Mert Akpinar, and password will be 123456, and in return what I need is my token, and then from user field I will have ID, email, and username. Let's hit that one and see the token. everything's fine. But what if I enter my username like that? We do have an error message here, user not found. Or maybe I'm just going to enter my password like that, and we now have an invalid creds message. Great, we got our errors working and we have an error message. We will be able to get that message and show to the user. If we had an UI, we could do that, but it's fine for now. So what I want to do next is making create product possible only if user logged in. So we can't create a product without logging in. So it's called authorization. We need a logged in, authorized user. And to do that, I'm just going to write a simple middleware. The logic here is whenever we make a request, we need to send our authorization header if we logged in. With that way, our server, our API, will know we have a valid token or not. If our API can decode the token and it's valid, user will be able to create product or do whatever operation is needed. And we got here actually a token. So let's log in again. Hit that one. We now have a token. I'm just going to copy. This will be my bearer token. So let's copy that. And then whenever we're making a request for creating a product, we need to send our authorization header. So I'm just going to add a new header here, select authorization and put the value bearer and then paste that token here. So whenever we make a request, we are going to send that header. And if our route is protected, such as creating a product is a protected route, only logged in users can do that. Let's go back to our application to index.ts. We do have a connection here. And what I want to do is instead just returning our con object, look for an authorization header. In order to do that, what I'm going to do is create a new folder called middlewares, or you can call it utils. It doesn't matter. And the file name will be auth.ts. And then I'm going to import everything as JWT again because we are going to decode our token. And then I'm just going to declare an interface here of token payload, and the only field I have in my token is user ID, because what we did in our GraphQL schema here is just sending user's ID to our token and signing that. So whenever we decode that one, we will be able to get user ID, and the type of it will be number. We are just declaring an interface here for our token, and let's export const auth function. What will it do is just take a header as an argument, and the type of it is a string, and it will return an auth token payload. That's why we declared an interface here, just to define the return type. And this function will have the token from the header parameter. And if we go back here, this is the format for authorization header. So we are saying that we have a bearer token and we are inserting our value after a space. So what I need to grab from this string is the second element. First element is just the type of the token, but the value will be the second element. So what I'm going to do is use JavaScript split method and split this string by using the space, so that we will have two elements. The first element will be bearer and the second element will be our token. So let's go back there and do header.split by space, and then we will have two elements array, and we need the second one, but to grab the second one we need to use the first index because index starts from 0. And then if we do not have a token, we are just going to throw an error that says invalid token or something like that. And then I'm going to verify the token because it may be expired or something else happened. I'm just going to call JWT's verify method, and to verify that, the first argument will be our token and the second one will be our secret to decode the token. If we're signing a token like we did here, we are signing that with our secret, and this secret is hidden here. After signing our token, if we want to decode it, we are going to use that one because this is how we signed it. We go back here and pass the second argument process.env.token secret as jwt.secret, and then we need to return auth token payload, and we are going to say that as auth token payload. But before doing that, to see what our verified token look like, we can do something like this. We can store a response here, jwt.verify, and the same thing will go there. Let's just do that. And after that, I'm just going to console log our response. So let's hit save. To use that function, we are going to go our index.ts file and change this context body. I'm not going to directly return that, so I'm removing this parentheses, and I want it to be a function. What I'm going to do is just return an object that has our connection, so everything will be fine with our type declaration here. In order to get our authorization header, we need to access our request, because if you dealt with HTTP servers before, this is actually the same thing. Whenever we hit that one, we are actually making a request to our GraphQL server. So inside of request, we have declared our authorization header like this, and to access that, we need to grab our header from our request object. If we go back there, we can grab our request and response from that function's argument. We don't have to do anything because it is provided for us. I don't need REST at the moment. All I need is my request, and what I'm going to do is grab the token, and we are going to check if we got request, headers, and then authorization. What we are going to do is pass that value to our function auth here, and rest will be handled by that function, but let's pass that out. So I'm just going to call auth here from middlewares and pass that one here. Otherwise, I'm going to assign null to my token, and after decoding my token, I have it right here, and what I'm going to return is, besides com, I'm going to return a user ID, or you can directly return the token. It is up to you. But for now, let's just not return anything, because our priority is to understand what this result looks like and what will be returned from the verify method. So I'm just going to hit save here, and then let's see, let's remove this one. We will call that one, so we will be able to see our response in console. I'm going to save. Going back here, we got our authorization header, and I'm just going to create product. We got a problem here because creator ID cannot be null, but if we go back here, we see that our result looks like this. We have an user ID here, and IAT is the expiry time, and we don't care about that. All we need is our user ID, and in order to use that user ID, I'm going to send that user ID from my token.userID, because we do have an object as a token, and inside of it we do have two properties. First one is user ID, and that's what I'm sending here. And let's get rid of that. So cool. Let me go back here. We got a problem here because we need to go back to our context and add our new field to our type. Type of it will be a number. And going back here, also we need to declare a constant here as we did before. Also, it can be undefined because the problem here is we may not have an authorization header and we're returning null, and we are trying to grab user ID field of something null, and we need to declare number or undefined, and it's all good now. Okay, we are passing our user ID in our context, so let's go back to our product schema and change it to something like this. Also, I'm going to need my context, and the type of it will be context, and I'm going to grab user ID from my context and check if there is a user ID or not. If it's not, that means user did not send an authorization header or our token is invalid, so we are going to throw new error here, and saying that can't create product without logging in. Otherwise, we can create a new product and we will specify our creator ID field here as our user ID that comes from token. And I'm just going to hit save here and go back. And let's try that again. My first product. First. I don't know why it's red, so it means that it's not working. Our server has stopped, so let's go back here. Maybe we need to delete that folder again. Actually not, because we have stopped our server and didn't restart it. So let's go back here and then create product again. We have a product here, and let's go back to our query to get all products, and we do have all products. So let's create another one, and the second one, the price will be $13.99, and create product. Great. Before the last verse, I just wanted to add something to our object type, our product type, because we have added a new column and creator ID does not exist on our schema. Also, maybe you want to get the creator details. And to do that, let's first add a non-null field, but let's do that here. So non-null integer actually. First, let's add the creator ID. And now we will be able to get our creator ID from our queries or whenever we create a product using our GraphQL server. And other than that, I'm going to add another field that does not exist on our database. So t.field, and the field will be created by. So whenever we make a query to get all of our products, or whenever we create a new product, we will be able to get this field on our GraphQL schema. Even though it doesn't exist on our database, it is useful to have a field like that so that we can get the details of our creator. And our fields type will be user, because we have a user type and we are going to get that here. Now I'm just going to call resolve function and take those from here. I'm calling resolve because I want to fetch user data using my creator ID. And this is the first time we are going to use our parent argument here. In the beginning of the tutorial, I have said that we are going to use that, but we haven't used that so far. What this returns is a promise, because we will deal with our database, and this promise will resolve to user or null. And then what I'm going to return is user.find1. I guess we forgot to put this one here, so we're good now. And I need to import user entity and then pass parameters here. We have var operator, and our ID field will be equal to our creator's ID. But how can we grab that one? We can grab this creator ID field by using our parent argument. Parent will point to our product object, because at the moment this is a child of our product type, and we are calling parent to access the object type. And we have a creator ID field inside of our product object type. This user can be accessible by this field. So I'm just going to hit save and go back to my studio. Whenever I create a product, now I can grab my creator ID, and also we do have an object here, and this object has our user type, so we can grab our username, ID, password, or email, and then let's just create a new product. This will be my third product, and create product. As you see, we now have a creator ID. This is 4. And created by field has the information about our user. So I just wanted to show that it might be useful for some scenarios, such as you have a homepage and you got all of our products in your homepage, and you want to add a tag that says created by, and then you need creator's username right there, and With that way, you can get the details of that creator. We have implemented authentication and authorization using JWT, and that was all I wanted to talk about for that tutorial. We have built a simple application that uses ApolloServer, GraphQL, PostgreSQL, and we do have authorization and authentication. Also, we have declared a relationship between our database tables. Even though these were all simple steps, I think it is a great starting point. And you can also add updating and deleting by using authorization, because we are passing our user ID to our context, so we will be able to access it from all of our resolvers. And you could check if the person making the request to update or delete a product is the person that is the creator of that product. So it is up to you. If you got any questions, let me know in the comments, and let me know if I should do more content in English. Thanks for watching.